In this video, we will discuss how to convert between two different compounds in a chemical reaction. And the way we will do that is we will be using something called the mole bridge. And what the mole bridge does is it is just setting up ratios. So for example, if I have this reaction down here, I can basically say that two H2s from just right here will be equal to 1 O2, and just from the coefficient that has a 1 there. And that's going to make us our life a little bit easier. And what we will typically do is these coefficients we can think of as moles. Okay, so 2 moles of H2 equal 1 mole of O2, which is also equal to 2 moles of liquid water here. Okay, I'm gonna give you a general guideline. There is a roadmap for stoichiometry, just like there was a mole map in our last unit. Chances are you won't even use this, but it is here that if you would like to use it as you start learning this, that's totally fine. Things that are going to be important is we need to make sure we have a balanced chemical equation. It's generally best practice that we're going to underline whatever we're given and then circle what we're trying to find. That way we can organize everything before we get started. And then if we're given something in some kind of quantity, the first thing we're going to do is we're going to convert to moles. And then we can use the mole bridge to convert from one substance to whatever substance we're asked about. And then we may need to convert back to grams or liters or something. But let's go ahead and do some practice problems to see how this works. So in number 1, it says how many molecules of ammonia, which is NH3, that's what's in window cleaner, will be produced if we have 1.2 times 10 to the 23rd molecules of hydrogen gas, and we have unlimited amounts of oxygen gas. So we are going to convert to molecules of ammonia. Okay, so the first thing I'm going to do is I'm going to write down what I'm given, and I'm given 1.2 times 10 to the 23rd molecules, which I cannot abbreviate MOL because that's moles, and it's molecules of H2. And I'm going to just convert here. The first thing I want to do is I want to convert to moles, so I'm going to say, okay, I'm going to go from molecules of H2 to just moles of H2. And unless we're at the mole bridge step, which we'll talk about here, our moles are always going to be 1. And in 1 mole of anything, there are 6.02 times 10 to the 23rd of that thing. So now I'm at moles of H2. And then to get moles of H2 to cancel, I'm going to put that down here. And I'm at the mole bridge step, okay? And what the mole bridge step does is it allows me to convert between hydrogen all the way to ammonia. So I'm going to go from hydrogen to ammonia. And the only way I can convert between substances is by using moles. So we'll go to moles of NH3. And like we talked about at the beginning of this video, these coefficients tell us exactly how many moles we need for a mole bridge. So H2 is 3, and NH3 is 2. And now if I stop the problem, I would be at moles of NH3. But what the problem asks for is molecules of NH3, so I'm going to go one step further. And I'm going to say that in 1 mole of NH3, there are 6.02 times 10 to the 23rd molecules of NH3. And I can math that out. And when I do that, I get 8.0 times 10 to the 22nd. And it is molecules of NH3. Let's just double check that our units did cancel. Molecules of H2 cancel, moles of H2 cancel, moles of NH3 cancel, and so I'm left with molecules of NH3. And this step, whenever we go from moles to moles, but we change substance, this is our mole bridge. Okay. So let's look at another problem in B, and we're going to use the same reaction. So I'm going to copy and paste that down there. Okay. So we are given the same reaction, and we want to know how many moles of ammonia. That's what we're solving for. If we started with 5 moles of hydrogen gas, and we still have unlimited amounts of, it says oxygen, but it should really say nitrogen. Okay, so I'm just going to write what I'm given, 5.00 moles of H2, and I need to convert to ammonia. And so now that I'm at moles, that means I'm at my mole bridge step. And so I'm going to put moles of H2 down here, and I want to convert to ammonia. And there are 3 moles of H2 for every 2 moles of NH3. And so when I math this out, I get 3.33 moles of NH3, and that one was actually not so bad because I just needed moles. If I'm asked for moles, that's not typically going to be a very difficult process to solve for. And again, this was my mole bridge step. Okay, I'm going to jump around on some of them. Let's look at number 2. We are asked how many grams of KCl would be produced if we use 2.5 grams of potassium solid, and then we have excess chlorine. So the first thing I want to do is write down what I'm given, and I'm given 2.5 grams of just K. And then hopefully you're starting to see a trend. The very first thing you want to do is get things into moles. Right now I'm at grams, and so that's not moles, and so I'm going to put grams of potassium down here. And I can always get to moles in one step, and so we'll put moles of potassium here. This is not a mole bridge step, so I know that that mole will be 1 for potassium. And if you remember back to our last unit when we talked about molar mass, I'm just going to get the mass of potassium from my periodic table, and that's 39.10 grams of potassium for every 1 mole. Now that I'm at moles, I'm at my mole bridge step. And I'm going to say moles of potassium, and I'm going from potassium all the way to KCl, so I will convert to moles of KCl. There are 2 moles of potassium according to my balance reaction for every 2 moles of KCl. And then if it asked about moles, I could stop, but it asks about grams, so I'm going to go one step further here, and I'm going to say in 1 mole of KCl, I'm just going to get the molar mass of KCl, and that is 74.55 grams of KCl. And now I'm at the correct unit, and I can math this out, and when I do, I get 4.77 grams of KCl, and that's my final answer. Let's look at another example. I want to look at number 5. This one asks, determine the volume of oxygen, and my reaction I'll have to write. And oxygen combines with lead-2 sulfide, and specifically 305 grams of lead-2 sulfide, and we're going to produce lead-2 oxide. So oxygen, of course, is O2, and it's reacting with lead-2 sulfide. That is Pb with the +2 charge, S with a 2- charge, so that is PbS. And it doesn't tell me the state of matter, so I don't necessarily know it, but I do actually know this just because I've dealt with lead sulfide before, and it's a solid, and it's going to produce lead oxide, lead-2 oxide. That's going to be PbO. That's a solid as well, and then sulfur dioxide gas. And I just know the states of matter, so just ignore those. And to get this balanced, I could put a 2 here. A 2 here, a 2 here, and then a 3 there. And that'll do it. And I'm starting out with 305 grams of PBS. And what I know is that I'm ultimately going from PBS all the way to O2. So the first thing, because I'm given just grams, is I need to get moles. So I'm going to go from grams of PBS to 1 mole of PBS. And to get the grams, I'm just going to look at the periodic table. Lead is 207.20 and sulfur is 32.06. So if I add those two up, I will get 239.26 grams of PBS for every 1 mole of PBS. Now that I'm at moles of PBS, I am at the mole bridge and I can go to oxygen. The only way we can convert between different substances is by using the mole bridge. And the mole bridge just uses a coefficient. So I just look up, and lead 2 sulfide was 2 and oxygen was 3. And then I can say, okay, now that I'm at moles of oxygen, it asks for me to get the volume, and that would be liters. And I'm at STP, so that is where 1 mole of gas equals 22.4 liters. So I can say 1 mole of oxygen at STP equals 22.4 liters of oxygen at STP. Now that I'm at liters, that's what I needed to solve for. And so when I math this out, I actually get 42.8 liters of oxygen.